Okay, let's do a little application of these things and change the topic a little bit. So here's the problem. So this is an application and example of a real trig substitution. So here's the problem I want to look at. Okay, so I have a circle whose radius is A. And I cut out from it a sort of tab here, this tab here. And the height of this thing is B. So this length is a number B. And what I want to do is compute the area of that little tab. That's the problem. So there's an arc over here, and that's what I want to find. I want to find the area of this for A and B, in terms of A and B. So the area, well, I guess one way to compute the area would be to take the integral of y dx. I think you've seen the idea of splitting this up into vertical strips whose height is given by a function y of x, and then you integrate that. That's an interpretation for the integral. The area is given by y dx. But that's a little bit awkward because my formula for y is going to be a little strange. It's constant value of b along here, and then at this point it becomes this arc of the circle. So working this out, I could do it, but it's a little awkward because expressing y as a function of x, the top edge of this shape, it's a little awkward and it takes two different regions to express. So a different way to say it is to say x dy. Maybe that'll work a little bit better, or maybe it won't, but it's worth trying. I could just as well split this region up into horizontal strips whose width is dy and whose length is x. Now I'm thinking of this as a function of y. This is the graph of a function of y. And that's much better because the function of y is, well, it's the square root of a squared minus y squared, isn't it? That's a squared plus x squared plus y squared equals a squared. So that's what x is. And that's what I'm asked to integrate then, the square root of a squared minus y squared dy. And I can even put in limits of integration. Maybe I should do that because this is supposed to be an actual number. I guess I'm integrating it from y equals 0, that's here, to y equals b, dy. So this is what I want to find. This is a formula, an integral formula for the area of that region.